What's up, everyone? Welcome back to another video. In this video, we're going to be looking at a tutorial for how to implement a parallax effect for text and some other elements on the page using just HTML, CSS, and JavaScript. So just plain vanilla JavaScript, no third-party libraries, no dependencies, no jQuery, just JavaScript. So here's a quick demo of what we're going to be building today. So as we scroll down the page, you can see that this is actually white text, but it breaks apart into RGB components. So that's actually a CSS property that we'll look into. And then these circles move off the screen as well. And then we have other text on the screen that's animating in. And then we can control the translation of this text sideways as we scroll. We can control fade and blur. And we're also animating the translation of some large black divs, basically, that are overlaying the entire screen, making it look like kind of a shutter effect, like we're closing the shutter on a camera. So yeah. So full disclosure, I don't think they'll have time to do everything on this example demo, but the source code for all of this is available on GitHub. It links in the description if you want to check that out. So yeah, without any further ado, let us go ahead and get started. Okay, I'm going to open up the current directory in Visual Studio Code. And currently, we just have a simple Docker file. And don't worry about this if you're not familiar with Docker. All this is doing is just serving the local directory using an Apache server. So first thing first, let's get rid of this guy. Let's get rid of that. And we're going to get rid of these guys as well. So we're going to be starting completely from scratch. Okay, so I'm going to get rid of that too. All right, so, and then we're going to get rid of that Git directory as well. So we have a blank website here. So the first thing we can do is go to index.html. And if you press the exclamation key once, then press enter, it actually inserts some boilerplate here for a blank HTML document. So I'm going to just to demonstrate real quick. Hello world. Got to be different, you know. And if I load this, it's going to show the same thing because I have got the other server still running, of course. If I start this server, what I have to do is do Docker compose up. And the first time it loads, the first time it boots up, it has to download some packages and such. But this stuff actually gets cached. So the next time I boot up, it should start automatically. And it looks like we have an issue because of a name conflict. Let's go back to the other directory and do Docker compose down. Actually, you know what? I'm going to open up Docker and manually delete my other instances real quick. So apologies. We'll get this up and running in no time. So let's delete that guy. And let's delete this too. I'm not sure what this web service is, but I'm pretty sure that I'm not using it. Okay, now we should be good to go. So we're going to do Docker compose up. And fingers crossed that this time this actually works. Come over here, localhost 8000. And why is it still loading the other one? So something's obviously being cached. I think maybe if I bust the cache here, it's not running, obviously. Start up the server again. There we go. Okay, I just had to bust the cache. Problem solving in real time. That's how it works. Okay, so we have a blank canvas. We've got a place for us to work our magic. So the first thing I'm going to do is I'm going to add a style sheet. So let's come in here. I like to nest all my styles in a CSS folder. Let's just call it styles.css for lack of a better name. And just to make sure this works, I'm going to do a quick test. Background color red. And you got to come back to index.html and add a link tag. See this autocomplete CSS. There we go. Perfect. So then we want to actually do CSS / styles.css. And I think this is usually written as style singular. So we'll just follow the convention doing it that way. And we have our red background. Excellent. So that's proof that this style sheet is now working. So I'm going to actually add kind of a reset. I want everything to have a margin of 0 and everything to have padding of 0 as well. And let's define some sane defaults as well. So I usually like to define my typography first. So H1 all the way through 6. In fact, you know what? I'm going to define the styles on H1 first and then copy them over. So, and before I do that, I want to come over here to Google Fonts. So we had Oswald. Let's just do 500. We're going to select that style. Come back here and let's also select Roboto Mono as well. And for this one, we're going to select, let's just do 300. Okay, and then we're going to come over here and do link tags. So copy that stuff and we can just add that into our index.html here. And it's important to load these before our style sheet. And then our font families here. Load those guys in. So for the entire document, so I'm going to set them on the highest element possible, which is HTML and body. Let's say that we want things to have a default of Roboto Mono. But then I usually like to also add classes for my font families as well. So we got Roboto Mono, and then we have Oswald. And here we're going to do Oswald as well for H1. Now, what I want to do for these guys, let's just do something arbitrary, like a 10 EM. That might be kind of big to start out with, but we can always tweak as we go. So line height, let's do half of what the font size is. And let's see how things are looking so far. So we have select all the ones here. It'll multi-select by holding down the command key. And then we have our 6 different headings. So quite a bit of space in between heading 1 and heading 2. So already this is looking a lot better than it was before. Now, one other change I want to do is I want to come up here and I want to set globally, we want to set the background color as black. And we want to set the foreground color as white. And already that's going to look a lot better, less straining to the eyes. And I don't need nearly as much line height, I believe. So let's just come down here. We're going to walk these down by 2 EMs at a time. This is going to be H2 and then H3. Let's do 6. So that might be a bit too drastic of a change, but we can always come back here and tweak these later if we need to. So let's just see how that looks real quick. That actually looks pretty darn good, I think. So might actually make this a bit larger. Let's do 16. Yeah, okay, we have kind of having an exponential increase happening there, which I like. And for the last 2, we'll just walk them down by 1 each time. And for an H2, we're going to make that 2 EMs. By the way, we want to specify what is an EM, so font size for the entire document. It's going to default to 16 pixels, but I feel like it's good practice just to set that anyways. And what's cool about this is that we can globally change whatever the default font size is. So if we set that to 12, it's going to make the entire document fonts everywhere smaller. Or like you can say that the default font is like 20 pixels. And now everything else is going to kind of resize based off of that. So kind of a cool trick. So we have our base typography done. All right, so, and then I don't want to spend a ton of time on the other possible elements. Usually you would want to also specify styles for the other display block items, like a paragraph, block quote, list item. Let's see, what else is there? I'm sure there's other stuff I'm not thinking of right now, but we can just set a default font size of 1. My commands here in VS Code. So font size, let's do 1 EM, and then let's see 1.5. Let's do 1.3 for the line height. So not quite 1.5. And then we're going to add some paragraphs here just to test that out. And VS Code has a nice lorem snippet here that we can do. We're going to do 2 paragraphs. All right, there's our paragraph. All right, I think that I want a little bit more line height, so I'm going to come back here and... Okay, that is good enough for now. Now for all of these elements, we want to add some default margin. And let's do half an EM for this. Let's see how that looks. I'm going to have multiple paragraphs to see how that looks. Let's make this a little bit smaller here. Okay, we want a bit more margin between paragraphs. So let's do 1 EM of margin. So now that's looking pretty good. Now notice that as a consequence, our headings also moved by quite a bit. I'm not going to make the margin relative. I want to make it a set pixel amount for everything, because I don't want these guys to be so far apart. Like that's margin between them right now. So, and this is going to be the last thing that we do for typography because we want to move on. So let's say 30 pixels, and actually 1 EM again is going to be 16 pixels, right? Because that's what we set up here. There we go. Typography is looking pretty good. So that was just a really quick and fast way of doing this. Okay. So we're recreating the Parallax title that we found, that we saw in the demo at the beginning of this video. So let's go ahead and make 3 of these guys. We're going to nest them inside of a div. And I know that I'm also going to want another div as well. And the reason for that will be apparent here shortly. So these 3 guys, first thing we want to do is center them on the screen. So let's add some utility classes to center some stuff. Okay, so we have center, align items. This is going to affect the flex alignment, justify items, center, and then text align, center. And then we can also do align self, center, and justify self. So I might take those off later because sometimes the align self and justify self mess some stuff up. So we can revisit that later, but let's move on to the next class. So then let's see, we want to do position fixed. Let's just say fixed is position fixed. And let's say fill is, there's a few ways to do this. So one way to fill something is to do it using flex. Another way is to use absolute positioning. And we're going to use absolute positioning for this because we want to have something on the page scroll while another thing on the page doesn't move relative to that scroll. Let's actually call this to disambiguify. Bigify? How do you pronounce that? We're going to call it fill absolute. And it's not going to be position absolute necessarily. But anyways, I digress. All right, at bottom, left, and right. So let's call this something different. Let's call it clamp. Okay, so clamp edges. How about that? So clamp edges is going to basically just set the top, bottom, left, and right to 0. So come back here to this guy. Oh, by the way, let's add. I'm going to do this position fixed and position relative. Yeah. Then we're going to have position absolute. Beautiful. Okay, let's come back here and let's go to class equals center, and we're going to do position fixed and clamp edges. And then we're going to come here and do position relative. And there we go. So now, one problem with this is that because we have made these things absolute, or rather fixed, it actually has broken the document flow so that this thing currently has a height of 0. So there's nothing to scroll. There's no scrollable elements on the page right now. So we'll have to add some content to give it somewhere to scroll. So one way to do this is actually just to give it a min height. So let's add some height classes. Let's just call it scroll fill 100 is going to have a min height of 100 viewport height, or 100 VH. Scroll fill 200 is going to have 200, and let's add one last one with 3 times the viewport height. So now, if I come here and do scroll fill 200 on the position relative, this guy here, all of a sudden, we can see it is actually scrolling. It's kind of hard to tell, but this is scrolling. So if I add a linear gradient, it'll be easier to tell that it's scrolling. All right, and that looks really ugly, but we love it. Actually, that looks kind of cool. Anyways, that's good enough. The only purpose of this is to show the scrollability anyways, so. Let's just say background cool is that guy. And come back here. Cool, bam. So now you can see that the background is in fact scrolling. And how big is this guy? This is 1366 tall. Whereas the viewport is inner height. Oh, the viewport is only 683 tall right now. So it's pretty sweet. All right, next step is to position our parallax elements. We want to position each of these guys as absolute. Position absolute. And let's see if that did the trick. Wrong tab. Okay, it did. And I can prove that by offsetting some of these real quick. Let's actually do left. So as you can see, and then color is red. Yeah, so these are all kind of overlaying each other right now. Now, they're not centering because we broke its flow from its container. So the way to get around this is to add center. Well, let's see if center will work for that. I actually don't know if this will work or not. Nope. What we're going to have to do is add a utility class and call it full width. Let's call it this. Okay, so width is 100%. Also going to add some positioning classes as well. So okay. So we're going to add a full width, and then we're going to center those bad boys. And then they should be centered on the screen. Okay, sweet. All right, now, and these are going to be in whatever the position they were to begin with. Again, no, I take that back, because the offset is coming from the line height of these guys. So if I change the line height to like 16 pixels, that's that one element, and the other two are just this, they're unchanged. So that actually looks kind of cool. A nice stack effect there. Okay, so we have completed this first step. We have, I know that the Google font is taking time to load. I know there are ways to optimize that, but we're not going to worry about that. I'm not going to worry about that in this particular demo. So the next step is to start to animate these elements. Well, before we do that, let's learn about the CSS Blend Mode. So this is something really cool that I discovered recently. Yeah. All right, so we have multiply. So as you can see, some really cool stuff that we can do with just some basic CSS. And then another blend mode is going to be screen. So yeah, coming back here to our side here, let's clear out some of these tabs. Okay, so let's add some more utility classes. We have blend mode screen. Yeah, mix blend mode screen. And then we have multiply. So that should work. And one last thing we're going to do is add some color classes as well. So we have our background here. Let's go ahead and add background black. Background color white. Green. Red. And blue. And then let's also add the same color classes for the regular colors as well. Just doing multi-line select within VS Code to edit all of these in place. Now, if I were using a tool like Sass, I would definitely take advantage of some of the mix-ins. But for now, we're just doing this in good old regular CSS, so just keeping things really simple. So now that we have our color classes, let's come here and let's have some fun. So we're going to do these as mix mode screen. We're going to color each of these as a slightly different color. So let's do red, RGB, red, green, blue. And currently, nothing's happening. Of course. All right. Well, let's troubleshoot. I'm gonna get rid of this background. Cool. That was just to demonstrate that we have a scrollable area. So it looks like that the mix mode's not working. Must have named the class wrong. So let's come back here. Blend mode is what it's called, not mix mode, blend mode. All right, now pink. Why is it pink? Because I actually want to define these as RGB components, because the green is not going to be completely green. There we go. So let's come back here and let's add our RGB style. In fact, I am going to, let's replace green. Okay, perfect. And let's do RGB, so 0. There we go, perfect. And now let's do color red. Same thing for that. But just to be on the safe side, we'll go ahead and, for the sake of consistency, we'll just do it for all 3 colors. Can't see my cursor. That's one downside of multi-select sometimes. Okay, now we have our 3 colors. Beautiful. Now it looks like nothing has happened, right? It looks like they're all just still white text. But actually, if we offset some of these a little bit, so left, like -15 pixels, gotta add a unit. And let's do this one, let's offset it downwards. So top of 15 pixels. You can see that these are actually all of the individual color components, but when they're overlaid together, they will add to form the white color. So there's another form of this is actually to do blend mode multiply, and it'll have the opposite effect. So instead of adding together, the colors will actually subtract. Or I guess multiply would be a more accurate term, wouldn't it? So if I do multiply for these guys, as you can see, the union space between these 3 colors is black, and everything else has the original color. So it's kind of cool, kind of a cool effect. So sweet. We have our parallax text. Now the only thing that's left to do is to animate this bad boy. And this is where we're going to kind of design a rudimentary animation system. Let's come back here. We're going to add a JS directory. And I'm sorry, I just realized I always forget to do this, to make the text bigger on the screen. So hopefully this is a bit easier to read now. Okay. Yeah, so we're going to add an animation system. So we have a few options. One way to add animations is to use like class names and to use data attributes. Another way to add animations is to animate everything in JavaScript, and basically what you have to do is, look stuff up by class name or ID, and then kind of like manually tell it what to animate in JavaScript. What I kind of like to do is to do it via data attributes, because this way I can define the animation once, and then I can reuse that animation across different elements by just adding different data attributes. Let's go ahead and kind of give an example of what I mean. So if I come down here, so data animate mode, this will all become apparent of what this is doing here in hopefully a few minutes. So data value start, data value end, then data easing. I'm going to prefix all of these guys, these data attributes, with the same prefix. Let's say that it has a linear easing at the moment. So then we're just going to copy these data attributes over. And let's also do that. And thank the good Lord for my auto formatter working correctly. Sweet. So then, all right, so what we want to happen is that on page load, we want it to start at the transform of 0, 0. So that's going to be no change of where it was before. And then as we scroll, we want to change the transform. We want to offset the transform by a specified amount of pixels. So another thing we could do is to apply this relative to the viewport. I actually did that in my demo code. So I don't think I'm going to do that here, just to try to keep things as simple as possible for demonstration. But if you want to check out how to do this relative to the viewport, that is in the source code. So go check that out if you want to. So, but what we can do is like specify, I want this to fly a -1500 as we're animating. And let's say that we want this guy to go -500 on the Y. So we have kind of an XY coordinate system here. So like -500 would mean that it goes 500 pixels up. And then for this last guy, I wanted to do 1500 to the right. So -1500 means it's going to go left, the X component. And then positive 1500 means it's going to go right. And then -500 for the Y component means we want it to fly upwards. Now, one kind of last thing that we can do is we can have a little fun by changing the start positions ever so slightly so that we can have these guys kind of stand out from each other. So to negative, actually I'm going to do that in the X component. So -1, this guy's going to be 0, and then this guy is going to have a start of 1 for its X component. So, all right, now, right now, this is not going to do anything because we haven't added any JavaScript code to handle these data attributes. So, and the last thing I'm going to do is to add an ID to the thing that I want to set as the scroll source. So what I want to say is that for this thing, for this container, I want to specify that this is the source. So the position of these elements should be based upon where this element is, how far it's been scrolled relative to the document. So I'm going to add an ID here, and let's call it, actually, let's call it title section. We don't have to be super specific because this is a demo app. This is not production code. So, all right, title section. And then last thing we're going to do here is going to add a scroll source, and they're going to call it title section. Title section, sweet. Okay. All right, this is what we want to do. Now, what we have to do now is to add the system that's going to animate based on these attributes. So coming back up here to JavaScript, let's add a new file, call it global.js. Sweet. And right now this is not doing anything, but I'm going to go ahead and add some test code really quickly, and I will explain in 1 second what this is doing. So on load equals an anonymous function. Beautiful. Actually, that should be good for now. And then we're going to document.query selector all selectors. I think that'll work. For knows that for each node, and node.style dot say background color equals to red. I think this will work. Oftentimes I've got some bugs on my code I got to go back and fix later, but the way to get this hooked up is to add a script tag here and then to give it a source, I believe. And we're going to call that source JS. And that's autofilling, so that is a good sign. Global.js. Now, if everything works correctly, this will fire, and our window.onload event should fire as well. And nothing is happening. Sweet. Okay, so this looks like it is loading. Let's actually document, let's do a good old console log. And that is not firing. Why is it not firing? Let's see. I usually like to look this up anyways, so let's do the window.onload event. Yeah, I thought that window.onload fired when the entire page loads. Let's copy the example that they have. So it looks like there are two ways to do this. We can use an event listener, or we can use onload, which I was definitely doing that. I'm assigning that to window.onload. Let's try the event listener and see if that works instead. Okay, still not loading, so something is going on. Try to troubleshoot and see what's happening here. I think what's happening is that I'm used to doing this in React, and with JSX you can do when you have an element, an HTML element that doesn't have any children, you can do this to close it, but that does not work in just plain old HTML. So let's try it again. It's now working. And this should also work as well. Beautiful. All right, so we have our script fired up, ready to go. The only thing left to do is to start adding some animation machinery. So let's explain first what's happening with this weird syntax, like what's happening here. So, well, basically all we have there is we have a function, right? So that we have our function inside of here, and then we're wrapping our function inside a set of parentheses. Okay, that is putting it inside of a block. Okay, this is putting it inside of a code block. So everything inside of the set of parentheses is going to JavaScript, the JavaScript compiler is going to evaluate this statement, and then we can go ahead and invoke that function. So this pattern is actually called an immediately invoked function, or IIF. So this is a pretty powerful thing to do. And the cool thing about an IIF is that this could be invoked anywhere in JavaScript, like pretty much literally anywhere. So I could even do like inside of hello world, like inside of here, like this is a statement, and this is going to be an immediately invoking function. So like, got to call the thing. So this last set of parentheses is going to actually call the function. So then this is going to call console.log again. So, and this could be kind of confusing because as you can see, the what up son, that got evaluated before the console log for hello world fired. So that could be a little confusing, but the reason for that is that we put this inside of a code block. That the set of parentheses establishes a code block. So that is in a nutshell what this thing is doing. Now, why did I do that? Why did I wrap all of my JS code inside of an immediately invoking function? Well, the reason for that is if I define any variables, they will not conflict with the global scope. So if I had some variables in a different file, for example, then what could happen is that I could start having things that kind of overwrite each other. So if I define a function here, what this is actually doing is it's setting my function on the window object. And I can prove that by doing this. So okay, so we have my func, right? If I run this again, look at that. That function, even though I didn't say I assigned this to window, it put it on the window object because we're in global scope right here. But if I nest this inside of my IIF, my immediately invoking function, that will no longer be the case. So I just refresh the page, and of course this is not a function. This doesn't exist. It's undefined. So this is what we call encapsulation. We are encapsulating all of our stuff inside of this scope, and that will isolate it from any other scripts that we have going on. So, prior to bundling everything down with Webpack and using Node.js, this was a very common practice, and really should be known that this is very important to do to avoid name conflicts. Like back in the day of using like jQuery, for example, it was very important to avoid clashing with other scripts. So this is one way to do that, to basically nest everything inside of an IIF, or immediately invoked function. Okay, so I took a long time to explain that. Let's keep moving forward. So we have our window.onload event. Okay, so we're going to load stuff inside of here. So let's add a function, and let's call it setup animations. And what this is going to do is we're going to get all of our nodes from the document that are going to be animated. So let's do document.querySelectorAll, and let's query everything that has a particular data attribute. This is why I like to use data attributes. Okay. And then if we do console log our nodes, then we're going to be able to see a big long array of the nodes that we have specified. In this case, we have specified 3 nodes that have this particular data attribute. So if I refresh, voila, we have not voila. We have 3 nodes here, and as you can see, they're the same guys. They're the same doodads that we specified earlier. Perfect. So we have grabbed the necessary nodes. Now we have to read in some of their values. So the first thing I want to do, I'm going to actually add a separate function, handle animated, let's call it node, and pass in node. If not node, this is called the early return pattern. It's very, very, very useful. Not no return, and actually, or not node.dataset. Also going to return then. Now, we're going to get some data from these guys. Now, when JavaScript reads in dataset values, it transforms the values to camel case. So these things are in dash case right now, but if I want to access this attribute, for example, the way to access it inside of JavaScript is to do this. So mode equals dot, right, so animate mode, yeah. And it also, it's going to, it's not going to include the data part of this. So if you ignore the data prefix and focus on the rest of the attribute name, it's going to be animate mode in camel case. So node.dataset.animate mode. And the same thing, we can do the same thing for this scroll source, value start, value end, and easing. Let's do that right now. I will fix the naming here in 1 second. We have our value start. We have our value end. Then we have our easing. Fix the casing there. Okay. So now we're just going to console log those guys. Let's do a node.id, do mode, value start, value end. This is just going to make sure that we are doing this correctly. So, okay, now let's, for each nodes, let's say if not nodes or not nodes.length, again, the early return pattern. This is a guard clause. We're guarding against the possibility of bad data. Now, I think that the query selector all will always return an array, but just in case, let's say that this changes in the future and this is abstracted out to a different function, like get nodes or something. And this just makes it perfectly 100% guaranteed that we're never going to have our script crash because it's trying to read length of undefined. This is a way to guard against that bad data. So now that we have our nodes, we know for certain that it is going to be an array. So we do nodes.forEach, and a for loop would be probably more performant, but the for each is easier to read, and it's perfectly sufficient for our needs in terms of performance. We're not going to have any kind of performance hit, at least any noticeable performance hit, by using for each instead of a regular for loop. So this should work. So we're going to log out everything in that list, and sure enough, we don't have an ID. Okay, I didn't specify an ID for these elements, but that actually should be fine. So remember, the first element had a start of -1, 0, and it went to an end of -1500, 0. And sure enough, we are reading in the data attributes for this first guy perfectly. Awesome. So now that we have those values, we got to do a little bit of extra work to get them into a usable format. So I'm going to add a function. This is kind of a tenet of functional programming. Have each function be responsible for one thing and one thing only. So we're going to have a function called parse coordinates and pass in our coords. It's going to be a string. So if, again, so we're going to do an early return if this is not data that we can use. So if not coordinates, we're going to return just a 0 and a 0. So we want to return an array with an X component. This is actually a tuplet, I think. A tuple is the technical term for the data structure, but just a two element array with an X component and a Y component. And then for each of these chords, we need to like parse the string value. So let's say this is just a JS doc to specify the params and the return value. So, okay, given a string like like 50, 100, return a two element array like 50, 100. So sounds easy enough, right? And sure enough, it is rather easy, but we're going to add a little bit of extra robustness just to make sure that works correctly. Let's say that the user gets confused and like they start adding parentheses and stuff. So the first thing we want to do is cast this to a string to make sure that it's a string. Replace. In any of these characters, we want to filter out. I think I've got to escape some of these guys. So we're going to filter out those guys globally. We're going to replace that with an empty string. Okay, let's chain that below here. And then now we are going to split by the delimiter of a comma. And now for each element, we want to map through it. Now split guarantees that it's going to return an array. So this is safe to chain map off of this split function. So each of these values, we want to return a numerical value for that value and provide a default in case the thing is not a number. All right, hopefully this makes sense. Let's walk through it one more time. This is a regular expression. I'm not going to go into regular expressions right now, but they are really, really powerful. What this is basically doing is telling that any of these characters, and I've escaped it with a backslash. So like if we have a curly brace or a square bracket or parentheses, we want to replace any of those characters with an empty string. Okay. And then we split it. This is going to take our string and it's going to turn it into an array. Oh, this has actually a description. Yeah, so we have a separator or a delimiter. It identifies which character we want to use to split or separate the string. And there's also an optional param called limit. We're not going to use that right now. So we're splitting this into an array of substrings. And then lastly, we are mapping through that and we're converting each element, which is a string, because split returns an array of strings, and then we're converting each element into a number and then providing a default just in case this is not able to parse whatever value it is into a valid number. It'll default to 0. So let's test this out. So we know that if the mode is transform, we want to let's do this. Let's do start. Actually, coordinates start. Parse coordinates of value start. Beautiful. And then same thing for coordinates end. We're going to parse value in. Now, I'm going to console.log out the coordinates start and the coordinates end. And let's see if we did that correctly. All right. So now we have a 2-element array or tuple of the X and Y components of this, what we want the start and the end positions to be. Sweet. All right, so that's kind of the first step out of the way. Now, in fact, I don't think I'm going to deal with easing right now. Just comment that out for the time being. We will need our scroll source. And what we want to do is we want to define a function such so that say use animate, or let's call it animate. And we got to pass it our element or our node, specify our scroll source, pass in our coordinate start and coordinate end. And I think that should do it. And lastly, let's add the possibility to debug as well. So we're going to do debug let's just call this a debug. So what the user will need to do is if they want to debug, they will need to set a data debug attribute like this, just to add some additional debugging to make sure things are working correctly. And we will likely need that before the end of this lesson, so or this tutorial rather. So if this exists and this is not equal to the string false, then debug is true. Okay, so debug. So this is the function we want to create. We want to animate this guy so that as we scroll, we're calculating the position of scroll source, coordinate start and coordinate end, and debug. So let's go ahead and do just that. So currently this will fail, but the next step is to add an animate function. Okay, so we have our animate function here. We're going to provide some defaults. Okay, and the first thing I'm going to do, if not node. Let me think about this for 1 second. So if not node, let's just return. Or we want to, let's do a warn. Yeah, let's do the console.warn was nil in perfect. I've not scroll source. Do the same thing for that as well. And this will just go ahead and exit out. And it'll also warn us that something was not set properly. Okay, so that's just kind of a sanity check, what I like to call it a paranoid check, because I'm usually overly paranoid about guarding against bad data, but that's just kind of the way that I roll. Okay, so we have a scroll source, coordinate start, coordinate end. So there's a few things that we need to get working first in order to get this thing off the ground. So we have to, one thing we need to do is, let's add some notes here. So, okay. Let's say things needed. Okay. We need to fire off an event based on scroll input. We need to capture the scroll behavior somehow. Number 2, we need to calculate the position of the scroll source. And the reason for this is we're going to compare whatever that calculated position is with the current scroll position. And that's going to tell us the percentage, the progress percentage that we are currently at in order to transform and animate those elements according to the scroll position. So yeah, get our work cut out for us. So it sounds easy, but we do have to do some calculations, some math calculations. So the first thing is probably the easiest thing to do. Let's go ahead and set up our scroll handler. one pattern I kind of like to do with this is, this is, very Reacty. React has hooks and it has like use blah, use X, or use state, use effect, or whatever. I like this pattern, and one thing I like to do is to accept a callback function. Provide a default there. And actually, let's call this on scroll event. So inside of this use scroll, we're going to add 2 event listeners. Let's do window dot add event listener. And let's do on scroll. Get nice autocomplete happening there. And I'll come back to that in 1 second. This is going to accept a second param for the callback function of the event listener. And we're not going to pass this scroll just yet. We have to calculate some other things first. So let's calculate the current scroll Y. And we're also going to calculate the window height. Okay, now let's also add window.add event listener of resize. And lastly, one reason I like to use functions on the outside and my, what do they call it, expression functions on the inside is that kind of like visually they look different. So inside of here, we're going to, let's see, let's get current scroll Y equals, okay, this is going to look up the window.scroll Y, and the current win height equals window.inner height. Lastly, we're going to call our onScroll event with our scroll Y. I'm just adding this signature because I can't use TypeScript inside of a JavaScript. And as you can see, on scroll shows the signature here because I defined a default for it. So that's just a VS Code thing. Completely optional. So we have current scroll Y and win height. Beautiful. Now, I gotta define a name for this function. Let's call this handle scroll. How about that? Handle scroll event. And to make it more generic, call it handle window event. Now you can see why we're doing this. So we are using the same event for both. Now, you might notice that right now we're not adding any kind of throttling or anything yet. So what we're going to do, we're going to add an animation loop that's going to basically throttle. So, all right, so we have our use scroll. Now let's test and see if this is working. So back up here on animate, use scroll, and we pass our callback function with our scroll Y. And all we're going to do right now is log out the scroll Y value. Okay, we're not doing anything else. And we are calling animate. Perfect. And this is a slight naming mismatch. Coordinates plural. Glad I caught that early before it was an annoying bug to figure out. And coming back here. All right. Scroll is working properly. We are firing off a bunch of events here. Now, what we could do is throttle this thing. Let me demonstrate real quick how we could throttle. So right now, as we scroll, let's actually add a counter so we can demonstrate this. Let I equals 0. And then on each event, we're going to do I++. Let's, instead of doing on scroll that, do on scroll I. And now All right, so in just a few seconds, we have like 118. Let throttle IT, the throttle. Now what we're going to do is we're going to do a window.request animation frame. Yeah, and we also need to add a tick is ticking false if is ticking return. I always need to look this up because it's a little bit counterintuitive for me. Request animation frame. So here's the documentation. The MDN docs have good documentation for this. And I always had to look at this guide to figure out what's going on. So we have the outside here, and they have the step function, and then you have window.request animation frame that's calling this. So it's kind of like, it's like a recursive function. So this is going to be a loop, which in this case, it's not a loop. We're going to request animation frame, which I could do on scroll as the callback, I think. So I think I will need a separate function for this. And then we're going to call our on scroll inside of here. We also got to do some calculations. Okay, now we are going to call window.request animation frame. If I can spell correctly, request, not even event listener. There we go. And let's call that on animation frame. What we'll also do is set is ticking is true. Think about this for 1 second. I think that I need to set. See how they accomplish it here. So we have start. Okay, they only use the timestamp to determine if it is the correct frame. So what we're going to do, instead of taking, let's do a timestamp and then prev. That's timestamp. So, right. So all we need is the previous timestamp. Right. And then if we do, if this has not changed at all, then return. Yeah, that's looking better. And then we're not looping through here, so we won't have to call the request animation frame again inside of there. We're just going to call our callback function, and we can move all of this machinery down here to this function, I do believe. And on this event, right, so we're going to need to do a request animation frame on every event. That's why I put it in a different function. Let's do this on tick. Okay, so we have I, and then let's do actually, to demonstrate the difference in these two. Theoretically, I throttle is going to increment significantly less times than regular I throttle. Do that. And we are good to go. All right, if I did everything correctly, then they are increasing at the same rate. Sweet. That should not be happening. Okay, so let me try to figure out what's going on here. So we have request animation frame. I would have thought that would buffer it so that each event fires, but this is not necessarily going to fire. Let's look at the documentation again. Yeah, so each step is going to be a certain number of milliseconds apart. So that's what is confusing me. I would have thought that this will fire immediately. That is true, but this will only sometimes fire because, yeah, I think that this is always firing the request animation frame regardless of whether we are it's always going to fire this. This is always going to follow through. So basically, like, the eye throttle is, there are going to be as many increments of the eye throttle as there are of the regular eye. It just happens, 16 milliseconds after the previous one. But it's still going to be the same number of events that are happening. So what we need to do is come up with some kind of status to determine if we are ticking or not. So we know that if an event happens when it's set ticking, so I was correct in my original assumptions. We need to add a is ticking false. Is ticking equals true. Now we also want to do set is ticking as false once we have finished animating, quote unquote animating. So I will explain this here in 1 second. So if is ticking return, we don't want to call request animation frame if we are taking. Now, since we added this, we don't have to worry about the timestamp at all. We don't actually care about the timestamp. Okay, so now, still not working. What the heck? Why is this not working? They're always incrementing the same rate. So is ticking true? Is ticking return? Yeah, this should be working. I don't know why this is not working. This increments every single event. It returns if it is ticking. Sets is ticking to true. Calls the on tick, which fires off this guy after a set number of milliseconds, which then increments the eye throttle, and then subsequently sets, it opens up this to be called again with is ticking as false. So why is that not working? This is called on every single event. Unless Chrome has optimized this somehow. Yeah, no, about paints. Anyways, okay, so we're getting kind of sidetracked here. What should be happening is that we should be throttling this and not firing this off on every single event. I'm not sure why this is not working, but this will be, I think this will be fine for demonstration purposes. Okay, so let's go ahead and get rid of our logs here. Is taking return, yeah. Yeah, now it's logging out here, our scroll Y. Okay, so we have successfully added our scroll handler. The next thing we need to do is we need to calculate the position based off the scroll source. And then progress percentage of the animation. Yeah, so then we need to calculate the progress percentage. So like how far along we have progressed on the document based on the scroll source and current scroll Y. And then lastly, we need to animate test stuffs. Okay, so we have done this. Give a nice check mark there. Next, we need to calculate the position of the scroll source. Node. Okay. If, again, this is the early return pattern. If not node, we want to return a default rect object, which is going to be top, left, blah, 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 bottom, left, righty. I think there's also a height and a width. I think that's all that we need. Okay, so then we're going to do get rect offset. Get bounding client rect. And this is going to return. Yeah, we're just going to, okay, here we go. That's what I need. So, okay, so left and X are always going to be the same. Y and top are always going to be the same. Perfect. Okay. That gives us everything that we need. So just for consistency, let's supply defaults for the X and Y as well. All right, so this is going to calculate the position of our node. So let's do just that. In our animate function, do use rect, pass in our scroll source, because that is really the thing that we care about, what its dimensions are. And then, oh yeah, so we want to actually pass in a callback. On rect equals this guy. And yeah, set all of these to be default values. So that's a little bit unwieldy to read, but this is going to say that we're going to call our callback function. If not node, we'll just return. And then we are going to do some slight refactoring here, and then we're going to call our on rect with our rect object, just like that. And because we supplied this default in the params, this default value, this function signature now shows up in VS Code. If we didn't have this, then this would just show up as something not helpful as like any, but because we supplied the default, VS Code actually uses TypeScript under the hood, and this can intuit what the type is. It is a type inference. It can infer the type. Okay, so we have our rect. So now let's test this bad boy out. I'm gonna come up here and use rect scroll source, and then on our callback function we have our rect, and we are going to console.log our rects. So back here in our app, get bounding client rect is not a function. Okay, let's figure out what happened here. Did I misspell it? It's probably the most likely explanation. Nope, I copied and pasted, so that should be correct. Well, let's log out the node and see what we're dealing with. Okay, title section. Oh, okay. So right now this is just the ID, the selector of the node. We don't actually have the DOM node yet, so we need to get that. So let us come up here to our function for, let's see, set up animations, and then handle animated node. How about handle animate node is probably more descriptive there. And then for our scroll source, we want to actually get the node from this. So we're going to do, let's see, document.get element by ID, and then that should be all that we need. And sweet. So we've got a DOM rect that has some positioning data here for all three of these guys. Sweet. And notice that this is actually the same thing for all three. So there could be an optimization where we actually calculate the rect one time instead of calculating it 3 times. But it shouldn't be a huge deal because this calculation only happens when we first load the page, or it's actually going to happen again when we resize the page as well. So actually, I don't think it'll happen when we resize the page. Yeah, it's always going to be the same. Okay, so we have completed that step. We have calculated the position. Now what we need to do is we need to calculate the progress percentage of the animation based on the scroll source. So that's the thing that we just passed in. And the current scroll Y, the thing that's going to come from the use scroll hook. Okay. So how do we do that? So we're going to do calculate progress. And given a scroll Y and given a rect, we want to calculate what is the current progress. We're going to assume that 0 is the absolute starting point and that 1 is the end. And we're also going to clamp the values so that we never go less than 0 and never go greater than 1. Okay, sweet. So this is just going to be a pure function, a functional component that's going to take a scroll Y, which is a number. It's going to take a rect, which is a rect. So I'm actually going to take this and do something a little bit, hopefully it makes sense. So we're going to do function rect, and let's do, let's see, what's the best way to do this? Let's do that. And then now we can, yeah. So I'm wondering if that'll, okay, so I lose my, the ability to have IntelliSense work, but this will be better for our purposes. So what this does, new rect, this is going to return this object. So it's kind of like a constructor. So let's do new rect for the default param there, because I don't want to repeat myself. And okay, we have a rect, and now we're going to have our scroll progress. So here's the kind of tricky part. We need to figure out a few things. Okay. Scenario 1. When the element first enters into view from the bottom of the screen, that's when start is 0. The percentage, I should say. when the element finally leaves the screen at the top, the progress should be 1. Assumption number 3. If the element is at the top of the screen and no scroll has occurred yet, progress is 0. And then lastly, if the element is at the bottom of the document and the scroll has scrolled all the way, and what's the best way to say this? If the scroll is maxed out, then the progress is 1. So that's 4 scenarios that we have to take into consideration. Okay. So now with our assumptions out of the way, let's get crack-a-lackin' on some math calculations. So the first thing we're going to do is, so we're always going to return a value between 0 and 1. That's going to keep it simple. So that this calculate progress function is concerned about only one thing, returning a value between 0 and 1. That way we can keep things nice and simple for us and isolated. Okay, so that multiplier is going to be 0 or 1. So let us let's see. We know that it's going to be a function of the min and the max. So let's first get the min and the max. So min, we need to figure out what the min and max are. So this could be the top, but now we'll come back to that in 1 second. So and then progress is going to be, let's do a multiplier. Let's call it progress. Yeah, we'll call it progress. And then we need to, let's see, min divided by max minus min. So I think that, let me think about this. So it's going to be a ratio scroll Y. Well, we also need to clamp as well. Don't forget about that. So let me actually do that real quick. Let's do it at a clamp function. So we're going to do math.min, math.max. So we want the max to be the max. Then we want the min to be the min. I think that'll work. Yeah. So that's going to clamp it. And we want to clamp the progress. Now we get to figure out, okay, let's do some maths. Whenever I'm figuring stuff out like this, I like to open up my Run.js program just to do a little bit of prototyping, some sandboxing. Okay. So min and max. Let's say so that min is 150, or min is 50 and max is 150. Got to figure out the progress. So, and then we have our clamp function. Let's go ahead and add that in here. Okay, pretty standard thing I usually like to do. So let's do min. Let's just like see what these numbers are. Okay, so we also need to have our current scroll position. Let's call it that Y. And that's going to be a function of min and max. So we're going to do clamp. Let's see. So I know I already figured this out previously, and I always like have to re-figure out how to do this. I could cheat right now and look at my previous code. That's it. I'm going to give it like 5 minutes. If I can't figure this out, I will cheat and look at my previous code. How about that? Okay, so let's set the timer for 5 minutes. Okay. So, we know that as we scroll down, eventually it's going to enter into the min, and it's going to leave at the max. We want that to be 1. So the max value is going to correspond to 1. The min value is going to correspond to, sorry about that. The min value is going to correspond to 0. So we definitely are going to subtract by the min. So I think it's going to be y divided by max minus min, clamped. And then if we do 50 will be 0, do 150 be 1. 150 divided by max is 1 minus the min. Let's see. Should it be y minus min? Yeah, I think it's y minus min divided by max. So in this case, I want this value to be 1 because 150 would be at the max. That would be 1. Let's see. 150 minus min is 100 divided by max. That doesn't make sense. Well, wait a second. Oh, I'm not doing the clamp function correctly. Okay. So this should be 1, but right now it's 50. Okay. Do that guy. Okay. And then we're going to clamp our progress down to min and max. Okay. So this currently is not working. Why is it not working? So yeah, I would subtract. Oh, it's going to be the difference of min and max. Yeah, so divided by the difference of max minus min. Okay, getting closer, getting closer. And then minus the min to offset it. This should work. So max minus min is going to be 100. That makes sense. Is it plus min? All right, no, I'm really confused. Why is that value not changing? Oh, I had these backwards. Thought I did. So let's see. Let's abstract these out. So what if the lowest value of, yeah, and then the highest value of, yeah, that should work. No, I don't want to save. Okay. All right, so y minus min divided by max minus min. Yeah, that should do it. That should do it. What the heck? I think my clamp function is still incorrect. So let me just test this without the clamp for now. Okay, that's 0. And that's 1. That's what I want. So, and then, okay, yeah, oh, I'm such an idiot. So I don't want to clamp to min and max. I want to clamp to 0 and 1. Beautiful. I did it in 5 minutes. Sweet. Okay, so I think this is a rudimentary progress function. Okay, now so that's the progress. We can just go and wrap that entire thing in clamp, and that will represent our progress. So now what we need to do is that we're just going to return whatever the progress is. Now there's one flaw here, and the flaw is that, remember that these two cases. So if the element is at the top of the screen, then its top value is going to be 0. Right. So, yeah, I remember. So I think what I need to do is this math.max. This guy minus, let's see, the viewport height, because we want, if the element, if the element is just coming into view, we want that to be 0. And so the scroll Y is going to be a viewport length away from the top edge of the element. So I know this is easier to explain with a visual, but for now, let's just do window.inner height, and that should do it. And then we need to do the same thing here for the rect.bottom. Do math. I think it's min. And then we want the maximum value to be whatever the document height is minus the window height. Is there a document inner height? Let's just double check that real quick. Document.height. So let's see, there's an answer for 2020. Document.scroll height. Nice. Okay, sweet. So bam. That should do it. So now we want to calculate the progress from 0 to 1 depending on the scroll. So calculate progress, scroll Y, and rect. So let's come back up here. So we have effectively, I think that we've checked off that third item, but before we can confirm that, we need to test this first just to make sure that this works correctly. So let's come back up here to our animate function. So this is where we're going to add our animation loop. And so on every scroll event, we want to animate the bad boy. Now I thought that I was using in this use scroll function the request animation frame. So in theory, we shouldn't be bogging down the DOM as it tries to repaint stuff on the screen. But we can always come back to that later and optimize later. So let's go ahead and just get this thing working. So want to get the progress. So we're going to get the progress from the current scroll Y. We need to get that rect somehow, but you might say, but wait a second, this rect is down here inside of this callback function. How do we get access to that inside of this? So what we're going to do, we're going to add this state object, and we're going to say that the, let's see, the current rect, actually, let's do a new rect just to have a nil object to work with. And then we have the current scroll Y. And then we're also going to do a scroll Y previous scroll Y, just to be more specific there. And every time we fire off this use scroll event, we're going to do state.prev scroll Y is equal to the new scroll Y. We're also going to set, I don't think, we might actually not need that on second thought, but yeah, let's get rid of that just for now. So previous scroll Y, and then we're also going to set the rect, state.rect equals rect. So that's how we have access to this rect object inside of our useScroll callback function. So we get the progress. We have our rect from the state.rect. So there's a calculate progress. And then we're going to do the scroll Y. We have that. And then we pass in state.rect. So fingers crossed. Let's go ahead and console log this out and see if this works. Indeed, invalid shorthand property initializer in 99. And that's because I have, yeah, so gotta just replace these guys with the colon, and then it should work. Y is not defined. Okay, so global, and that's at 123. I don't have ESLint installed because this is not an NPM project, a Node.js project. But that would help a lot in like preventing some of these dumb errors from happening. So 123. Okay, yeah, there's no Y. That makes sense. So I want to use the scroll Y there. Okay. And there's somewhere else is logging out. We don't want that to happen. So let's see. Where am I? Where am I? Yeah, we don't care about that for now. Okay. So it's always showing 0. Let's figure out why it's showing 0 right now. So let's go to our calculate progress and let's see, what does it think that the min and max are? Okay, so scroll Y, min, max, progress. And wait a second, this is not, why is it not logging out? So on every scroll Y, that should be firing, passing in our calculate progress. I don't think I saved the file. Yeah, I didn't save the file. Okay. All right, so yeah, min and max look correct. Oh, you know what? I didn't update my clamp function. I forgot to update the clamp function. So let's do that right now. Because remember I had that backwards. So let's, yeah, so the max and min should be reversed here. Whoops. And still not working. Let's just make sure that file was saved. Clamp scroll Y. Let's see, let's break this down a bit further so we can get some more visibility into what's happening. Progress equals and then clamped is clamped. And we're going to return clamped. Progress clamped. All right. Look at that. So we have, all right, so the progress is working. However, our clamp function still isn't working. Oh, goodness. It's always the dumb stuff, right? Okay, so we're going to clamp it with a min of 0 and a max of 1. And now it's working. Sweet. Okay. So we're going to get rid of that console log and come back here to calculate progress. And we're going to console.log out our progress. So it's kind of hard to tell. Let me add the background back here so you can tell what's going on. So as I scroll down, to the very bottom. Once I reach the bottom, the progress is 1. And when I get to the very top, the progress is 0. Sweet. So you might be asking yourself, we just spent all this time just calculating a number between 0 and 1. What the heck? Like, we're not doing anything yet. This is not impressive. And you're absolutely right. This is not impressive, because currently we're not animating anything yet. But let me show you how this is so powerful. Like, having a number between 0 and 1 is basically how all animations work. So if we have, first of all, we are going to, and if, first of all, let me add this real quick. So if scroll y is not equal to state dot previous scroll y, so we only want to quote unquote animate if, and let's do on tick. Okay, so we have our tick, and we're going to calculate progress. And now we're going to animate the son of a gun. So things needed. We have confirmed that we are calculating the progress percentage of the animation based on the scroll source and the current scroll y. Last thing we need to do is animate the stuff. So we're going to add one last thing, and let's add some transform functions. Let's just do this. Transform, and give it a node, and then we're going to say, okay, let's transform it. Let's transform in x into y. So x into y value. So, and then we're going to do if, again, early return pattern, if not node return. And then we're going to do node.style.transform equals translate. And I think this is just x pixels, and then y pixels. Yeah, and that should do it. And then so we come up here to animate, and we're going to do const x equals. So we get to figure out the x and y, and then we're going to transform our node by the x and the y value. So how do we get our x and y? So we're going to take our progress, and we're going to also get our inverse. 1 minus progress. Now, what we're going to do is, so remember those coordinates start and coordinates end that we passed in a long time ago and never used? So now we're going to actually use those. So let us say that start x start y equals coordinate start. And same thing for end. Okay, perfect. So now, and let's also give these default values as well. Perfect, looking good. So now we have start x, start y. We're going to do x is equal to start x times the progress, and then plus the end x times the inverse. So as the progress increases towards 1, the inverse is going to advance towards 0. And I can log this out real quick just to kind of demonstrate what's going on here. So if we log out console.log the progress and the inverse, let's see what happens. All right, so let me refresh the page. So when we first start, at the very top, the progress is 0, but the inverse is 1. When I scroll to the very bottom, the progress is 1 and the inverse is 0. So they're going to be inversely proportional. As the progress increases, the inverse is going to decrease. And this is very important because this way we can interpolate between the start x and the end x, and same thing for the start y and the end y. Just change these guys to y. And now we have an animation. Look at that. Heck yeah. So that's how you animate this guy. So now I'm a little confused because as I scroll back up to the top, I think I get these reversed. So let me check something real quick. So progress, start x times progress, y times progress. Yeah, I'm really confused here. Did I get the order of the params mixed up maybe? Coordinates start, coordinates end. If I check here, start. It's looking like the end values are somehow getting used for the start. So there's a bug happening somewhere. So let's figure that out. Up here, parse coordinates values start, end. Start is first, end is second. Parse coordinates value start is animate value start, value end is animate value end. All that looks good. Maybe I get the parse coordinates. Did I get the parse coordinates mixed up? I don't think so. That should be working just fine. So we're passing in coordinate start and then coordinates end into this animate function. Coordinate start, coordinates end. What am I missing? Start x plus end x times the inverse. Like the end should be this negative 1500. It should be flying off the screen as I scroll down, but for some reason it starts with the objects off the screen, and then at the bottom of the scroll section they are scrolling. Yeah, that's so weird. Let's log some stuff out and try to figure out what's happening. So actually let's do this. Let's do if debug. So we have our debug param here that we never used. So if debug, then console.log. Let's do no.id. So if that exists, it'll show the ID. If not, then it will just show nothing. And then we are going to actually just do node. Yeah, that'll show us. Just like print out the default display for a node there, and then we can display the X and the Y. And let's actually do the progress as well. And then we'll do the coordinate start, coordinate end, maybe. What am I missing here? It is not logging out because debug is not to set the true. Let's not worry about debug right now. Okay, so clearly it does think that these are the values. It thinks that. So let's just log out the start x, or coordinate start, coordinates end. Yeah, this looks right. Like the first array is the coordinate start, and then the second array is the coordinates end. So let's think about this for 1 second. Oh, wait. Inverse is 1 minus progress. So let's just double check the progress and the inverse real quick. because we know that the coordinates start and end are correct. Start x times progress. When we're at the beginning, that should be 1. Wait. Wait. I've got it backwards. I've got it, wow. That took me way too long to realize, and apologies if you like noticed that a long time ago and it was just painful to watch, but that's what happens oftentimes. I got these two things backwards because at the start, the progress is how far in the animation we have progressed, right? So obviously that should be 0 at the start because we have not animated anything. So the end should be multiplied by the progress value, and the start should be multiplied by the inverse. That's why everything was flipped. Oh my gosh, that took me way too long to figure out. So now when we load the screen, it loads like this. But then if we start scrolling, then it animates like so. What's cool about this is that we now have full control over the animation with these data attributes. So we can like change and tweak these values here in the HTML, and it's going to affect how it animates. I can even have this go down instead of up. Let's say we just want it to move a little bit, not a whole lot. You have them all go to the side even. Say we want like this to go to 250. So yeah, so just by tweaking a few parameters, we are able to animate this thing based on the scroll position. And what's cool is that if we add additional sections, you can see that this is going to be clamped to the position of the end position, whatever we specified for the end animation value. So let's say that you want to animate something only while we're scrolling through the first section, but not as we scroll through the second section. So if we add an additional section, then we continue to scroll, but this will stop. Kind of hard to tell that scroll on the right hand side, but if I add the background color, you'll be able to see this in effect. So that continues to move until this reaches the top edge, at which point it no longer moves because the first scroll source, okay, the first scroll section, the title section, has completed its full, it's gone through the entire, the full range of how much it can be scrolled, if that makes sense. Now, one last thing, you might have noticed it, but if you haven't, it's okay. Notice that I did set some initial values here, but they're not getting represented. So I've got a start of -10 for the X, and then down here we have 10 for the X, and currently that's not being reflected until I scroll. And after I scroll and we scroll back up to the top, then the start values are then reflected. So the way to fix that is just to go ahead and call this onTick one time at the beginning. And we can set another piece of state here to do initialized. And then we can do, as soon as we call the onTick function, set initialized to true. And then if, let's think about this for 1 second. So if we are not currently initialized, we want to fire off this onTick function. So let's do just that. And actually, I don't even need to do that because what I can do is just fire off the onTick and not worry about keeping track, because right now this is assuming that the user is only going to fire this animate function a single time for an element. So this could get problematic if, for whatever reason, like maybe the dev forgot that they already fired the animate function for an HTML node and they fired off a second time. Some weird stuff could happen because now we registered 2 on scroll events and we're calculating the rect 2 times, which that shouldn't really matter because that only really fires a single time. But then it is going to fire this scroll multiple times. So it's probably not going to be apparent what's happening because the scroll is going to be the same. But what it is going to do is going to affect performance. So a way to get around this is to like add like kind of a store and then register the node IDs. And then if the node ID is already registered, like don't fire this, don't like re-register all of the animations. And I actually did that in the code demo that I have mentioned a couple times before, just to prevent like the possibility of animating the same thing twice. But for this example, it's kind of overkill to worry about that. This is perfectly sufficient for our needs. So yeah, this is a demonstration of how to animate some text. Now, what are some practical applications? Now, what we could do is we could like wrap this thing inside of we could add some additional styling to make this more usable. One thing that I kind of liked is that maybe we want to have the next section cover up the previous section as it scrolls over it. So z index 10, that is the index of 10 here. And then, so let's say we just have another section down here. I'm going to call that a section. I'm going to do z index up to, now we also have to specify a position relative to cover up fixed position stuff in the previous section. So position relative for that. And then we're also going to do a background of red. Let's do some H2s and some lorem ipsum text. Looks good to me. Let's do some lorem ipsum text for this as well. That's not quite big enough, so let's go ahead and I haven't added any padding or anything to this, so it's going to look kind of wonky, but that's okay for now. Let's do center, and let's also do scroll fill 200. Now this will cover up the previous section. So now what we could do to make this thing animate through its full value. In fact, I think that we didn't quite calculate that correctly, because we want this thing to continue animating until it gets covered up, right? Right now it does look kind of wonky to stop animating before it gets covered up. So we have just one last thing to do before we can call it quits. And that's to figure out the correct point of when to stop animating. Okay, so I know that it has to do with our calculate progress function. So down here, the max, I think it's the assumption we made about the max. We took the math.min of the rect.bottom, and then, okay, I think I see what we did. So I think what we need to do is, instead of subtracting the viewport height, I think we need to add the viewport height, because you're taking the entire Wait a second. Hang on 1 second. So no, that's not correct. The bottom edge of the container should be at the top edge of the viewport when we're at our max. Yeah, so that would be scroll Y. Okay, that makes sense. So then, yeah, document height minus the viewport height, that would be the scroll Y. So I think that makes sense. Let's just set this to rect bottom for now, just to test my assumption. Let's see if that fixes the issue. Did not. Okay, when the scroll Y is... Yeah, that's kind of weird. That should be working. I'm not sure why it's not working. Because when the scroll Y is equal to the bottom of the element, then it should have just gone out of view. It should be at the very top of the screen at that point. So let us look at what's happening here. So here's our title section. As you can see, oh, wait, now it's, wait, what? It's still animating. Hang on 1 second. Now it's not working, okay. Yeah, there it is. The title section is currently still in view. Like, okay, well, let's do some testing here. So, document .get element by ID, and then title section, okay, for node, and then we're going to get the .get bounding client rect .bottom. I didn't take the height into account. I didn't take the damn height into account. Is that what it is? No, I think that... Hang on 1 second. Oh, wait. Oh my gosh. Okay. That's what happened. So I forgot that the get client bounding rect takes into account the offset as well, the current offset. So dang it. So what we need to do is to factor in the current scroll Y into the top and bottom values of the rect. So when we do the calculate rect, we need to, let's see. Rect.top. And then what do we need to do? So scroll, I think we need to add the scroll value to that rect, I think. Let's do plus window.scroll Y, and then bottom, do the same thing for that. And let's see if that fixes the issue. Yep. To be the case. So the issue earlier was that if I refresh the page when I was partially scrolled down, then on subsequent page loads, it would call this get bounding rect client again, get bounding client rect. And it was incorrect because so that value actually changes as we scroll down the document. So notice again, if I get my node, and then if I get top, right now it's -825. If I scroll up a little bit, now that value has changed to -402. So And it's always going to be corresponding to whatever the scroll value is. So if we do like .top and then check window.scrollY, that's going to be the exact, it's going to be directly proportional to and actually equal to the amount of scroll that has occurred. So it's kind of annoying, but I think that just removing the window.scrollY from the top and bottom is going to fix that. So I think that that actually works. So sweet. All right, I think that's going to be a wrap. This took quite a while to get this hooked up, but that's kind of the nature of the beast when we're hand rolling things, when we're doing things completely custom on our own. I would probably recommend using an animation library. One great library to look into is d3.js. And I probably will do some tutorials, hopefully, about this in the future. D3 is awesome. It's a much faster way to get animations working. And you can do a lot of really, really cool stuff with D3. Animating some globes. Like, look at that guy. Oh my, an orthographic projection. That's pretty sweet. So there's tons of examples here and like tutorials that you can go through. I would highly recommend using an animation library instead of hand rolling your own. Another thing that I just came across recently, is it called GSAP? Is that what it's called? Yeah, I think it's called GSAP. This is an animation library that I've seen people use, and it's also pretty powerful in what can be accomplished. There's another thing called Imba. Imba is actually an entire language. And it's full stack as well. This is something that I actually want to check out. And this is really good for animations too. You can animate clocks and such. This is just animating like the rotation of different objects. Also, the markup here is really cool and kind of very minimalist. So kind of reminds me of some Python with the indentation mattering there. Kind of like a mix between Python and, you know, HTML tags and stuff. So yeah, Imba is cool. So yeah, those are 3 different animation libraries that you should probably use instead of hand rolling your own. But I love doing this sort of stuff, kind of like hand rolling and customizing my own animations, like kind of seeing how things work under the hood. What's great about these other animation libraries is that they give you a lot of bang for your buck, and a lot of the problems that I was banging my head trying to figure out, you know, other devs have already done the hard work and figured that stuff out for you. So a long process to get to the point where, like, to say, probably shouldn't hand roll your own animations, but if you have to, hopefully this is helpful to give you kind of a start to some good pointers and good practices to follow, especially when using functional programming and using things like early returns and, you know, that sort of thing. So yeah, hope this was helpful, and let me know if you have any questions or comments. Feel free to check out my source code. If you're still here at the very end, thanks for sticking around and being awesome. I'm going to call it an evening, and this is Don signing out. Thanks for watching. Take care of yourself. Bye.